All right, here's our next question. We have a 900 kilogram car that exerts 5,000 newtons of applied force on a level road while being opposed by 1,000 newtons of friction. Determine the acceleration of the car. Here's something new. Make a qualitative force diagram. So that's a free body diagram first. So let's do that first. All right, so we have our dot or our box to indicate the car. Like I've done before, I always like to start off with gravity. However, we need to figure out the force of the weight of this car. The force of the weight is going to be gravity times the mass of the car, right? And we know gravity is a constant. It's 9.8, but we're gonna abbreviate it or round it to 10 meters per second squared. And the mass of this is 900 kilograms. So the force of the weight for this particular car, if I multiply 10 times 900, I get 9,000 newtons, right? It's important because my normal force has to be equal and opposite, right? Now, let's see how much or what other forces we have. It says we have 5,000 newtons applied force. Right? And then it's opposed in opposite direction by a smaller value of force of friction of 1,000 newtons. Okay, so that's what my free body diagram should look like. Now, I want to use this free body diagram to figure out the acceleration of this car. So my force of gravity, which is the weight, and the normal force are going to cancel each other out. So now I'm left with my acceleration, or excuse me, my applied force and my friction force to calculate the acceleration, right? So I want to figure out the force, the net force. These are not equal and opposite, right? They're opposite each other, but they're not equal. To figure that out, we're going to find the difference in these. So 5,000 newtons minus 1,000 newtons. My force, that's the net force, is going to be 4,000 newtons. Which direction? It is going in the direction of the applied force. Okay. Now that I have my net force, I know that I'm going to draw a little box here just to kind of help us with organization. Acceleration is going to be force divided by mass. I have my force, I have my mass, I can just plug those in. So acceleration is 4,000 newtons divided by 900 kilograms. Or I could rotate this newtons into kilograms meters per second squared. So I'm going to do that over here. 4,000 kilograms times meters per second squared divided by 900 kilograms. Kilograms are going to cancel each other out. That leaves me with acceleration of 4.4, and that's a repeating 4 if you plug that into your calculator, meters per second squared. And that's the acceleration of that 900 kilogram car.